Yeah.
Cool.
Yeah, good job.
There's a really cool idea, and of course, anytime I say that, I think it's cool. We'll see if you agree. Something called relatively prime. So, like the numbers 8 and 9, are either of them prime?
No.
No. But they are relatively prime because they don't share anything with each other. Do you see that? So if I had 1/8 plus 1/9, the LCD is 9 times 8. I don't have to think about it. They both need each other. Right? So I am sure as all hell not allowed to add something to the top and bottom of a fraction that does not maintain that fraction. Why does multiplying maintain it? Because the division would kill what I just multiplied, so it is the same thing. I'm just unreducing it when I multiply by something, right? Okay. So what's this guy missing? All of him. Aw. Does this guy have an M on the bottom?
No.
No, it doesn't, so he needs one. See what I'm saying? Does this guy have a 1 on the bottom?
No.
No! So how the hell would he be missing a 1? He doesn't even have a 1.
It looked right. It looked about right.
I know.
The eyes are
I know it looked right.
Yeah.
Well, we know when that happens. It happens. So this guy needs M plus 1. And this guy needs M.
So it just becomes m squared plus m?
We'll find out. You guys finish it up?
Yes.
Yeah.
Oh, you're talking about the bottom? The bottom don't multiply that. You know.
It's my insulin. There it is. Jeff, do you have any Thanksgiving plans? Cool.
Yeah, he's going to see it.
Just wanted to check.
Do you have Thanksgiving?
I'm trying to avoid them.
Not very good.
So one thing, remember when there's a minus in the middle. We know that's going to possibly screw us up. So my big suggestion is to make it like this, which doesn't look like it's much different. But then you see that it is a -4 that's going through, right? So we got 3m minus 4m minus 4, I like it. So then you get -m minus 4 over m plus 1.
Is it incorrect?
No.
Cool.
You can make the bottom m squared plus 7, that's fine. I'm just telling you, you don't have to.
You didn't let me finish.
All right, if that's what you're talking about, that's fine. What are you talking
I was talking about, is it... I don't know, man. I was gonna
Okay.
make a dumb joke, but...
about? I know, I was waiting for it. I'm like, I don't know if he's gonna make it.
I'm tired, you know.
Is it okay if I...
Is it okay if I spin on my head like a breakdancer? I don't know, dude.
Sure.
No, I can't do that. I can't do that. No. Stop trying to get me to breakdance.
It'd be funny if he's like, all right, he gets up here and gets that.
Yeah.
All right, so this first guy. So the whole idea is if there's a part of this that won't factor, that's awesome. You leave it alone. The other part factors. How does this part factor? Yeah. It's the GCF that always messes people up. I always see people have this and I see some stuff erased. I'm like, oh my God, you killed yourself at the beginning. That's not how it's ever going to factor. This, you just take an X out. And then what's this guy missing? An X. It's crazy. You guys all see that? You guys? And again, if you suck at factoring, you're going to suck at it. That's a given. This whole chapter is going to be horrible. I'm not saying that's so give up now. No, you focus on factoring because otherwise you can't do anything else. This guy needs an X now. And now they both have the same bottom. I like it. So then you get X minus 2 over. Yes, I like it. Said with the correct amount of enthusiasm. This guy actually looks worse, but it's easier because you got your standard form stuff to factor on the bottom. Believe it or not, these numbers here are kind of evil. Because depending on what's positive and negative, it could be 6 and 1, or it could be 2 and 3.
Mm-hmm.
And in this case, since everything's positive, it has to be 2 and 3. I like
Yeah, we got that in the first try, Spencer.
Yeah, I'm sure I did.
I really hated that high five and I'm mad at you about it.
I don't believe it as much as I want nothing. I want nothing.
That's right.
And what goes over here? And then what's the first dude missing?
1. Max plus 1.
There you go. You stop for a second. So all I did was I factored every denominator that I could. And then I just compared the two denominators to see why are they not like denominators. Because this guy is missing an x plus 1 for one thing. Now this guy's all happy. This kid's happy. This kid's crying.
Oh, he's great. X plus 3.
And yeah, I give him an x plus 3.
Yeah, good boy. He's happy now. Alright.
And he's still crying, so I ate his ice cream and sent him to bed. It's such a great
The
guy.
kid's still going to be crying because X plus 1 is going to be like, oh, he got more than I did. And
So he got X plus
now
1
it's a-
first.
now it's a whole
And they're
thing.
crying because they're like, this is algebra. We're just 3 years old. What are you doing?
We're in a college class. What's going on?
So,
Okay.
again, when there's a minus in the middle of things, and we know this from factoring like grouping, you gotta be careful about it. And in this case, the best thing to do, you don't have to do this, but write it as plus and negative so you can see the negative 2's going through. So what do I get here? 5x plus 5. What do I get here? And then the other thing is, sometimes I'll have people just cross these bottoms out. The only way there are two major things wrong with that. One is, if there was a times, okay, that's the first problem. It's not a times. But if it was a times, one of them would have to be on the top and the other one on the bottom for them to cancel with each other, right? So I think it's partially just people being hopeful, right? But you definitely can't just kill these. You just have to write it all. And then the top becomes
3x,
3x minus 1
That's what I wrote
over
the first
all
time.
this business. Bruh.
Yeah, it's because
Oh,
I
it's
mean,
the,
yeah, I did the same
minus-
thing.
yeah.
So it's actually minus 6 plus 6.
Yes, no, maybe so?
Yeah.
Yeah. Yeah.
Good boss.
No, tell me. Is it all right?
Just to grip the box.
All right.
It's alright if you say it's alright.
So last thing, then I'll let us out here a little early.
Yay! Alright, so that was cool.
We're done?
No, I said that.
Not yet.
God, I was like, huh?
So the next section, the last section of chapter 8, is all about what we're doing, but in equations.
Mm.
So I want to do one example with numerical denominators. Okay, so we got a problem like this. What you got, Jeff? So there's multiple ways of doing this. I'm going to show you a certain way that kind of works better once we get variable expressions on the bottom. So you might have been shown a different way to do this, but the way I do this would have been such a better problem if all of the bottoms were like 12. Because then how can I kill them all in one fell swoop?
Just take out the
By doing what to both sides? Multiply by 12. So if I can make all of the bottoms freaking 12, which I obviously can, right? Because 12 is the LCD. So what's this? What is this guy missing?
2.
2. Oh my gosh, what are you missing? Pink. Nice. Let me see what happens with this guy. Ooh, hello. Low order shit. That's good. And this guy needs a 4. So now I got 2x over 12 plus 20 over 12 equals 7 over 12. Now that I've made the bottoms all the same, I could just do what to both sides?
Multiply by 12.
Multiply by 12.
Yeah.
And actually, if I multiply this side by 12, wouldn't I Distribute that. Yeah, of course I would, right? If I multiply this side by 12, would I not distribute it?
Why are you,
Yes.
why are
Sorry.
you multiplying by 12?
Why is this equation gross?
It's fractions.
It's fractions. Why is it fractions? Because some of them have 12s on the bottom of them. What operation is that? Division. So how can I kill that part that I don't like? Multiply. So if I multiply by 12, and the way I write it is just next to each term because it would distribute to both, then they all die. Now, I have a special place in my heart for those poor people that somehow that 12 survives and makes these numbers big. It dies, right? So then what do I have left?
2x plus 20 equals 7.
And that is way kick-ass. Right? Much, much better than it was to begin with. And then I just solve this like normal. Subtract 20. Divide by 2. 10. Alright. So last example. Now we're going to do one of those with variable expressions on the bottom.
Did you say why?
Because it would be mean if I didn't explain it.
Right.
I just gave you a test.
Yeah. Very rude.
Here's real life, kids.
Yeah.
Toothpaste, orange juice, there you go. What can be worse than orange juice and toothpaste? Lots of things.
I don't know.
You ever been hit by a car, Spencer?
All right, make that list later.
It wasn't Fred, by the way.
Nope. So how do I start this thing? Good. So the first step is factor what you can. So you see what it's made of.
It's made of.
Forgot which one was bad.
Cool.
So this one would become what?
X plus 3, X
Isn't that insane? So a lot of these problems are going to have hints in them about how to factor the parts you can factor. Look at what the other things are and go, oh, maybe it's that. So if I can make everybody have that as a denominator, I can multiply by that. And they will all die. There won't be any fractions, which is a really good goal. Why am I allowed to kill these fractions? And I couldn't kill the fractions we were doing earlier because these are in an equation that has two sides that I'm allowed to multiply both sides by something. That not there, I like that. That not there. If that is not there, then I'm not allowed to kill the fractions. I can't change my expression like that, but since I have an equation with two sides that balances out, I can kill the fractions. So what does this guy need?
One of them. I messed up. X minus 3?
Thank you. And this guy needs?
The X plus 3.
Okay, so then I can multiply by, I actually multiply by x plus 3, x minus 3.
Oh, so I didn't need to write out X plus 3, X minus 3 times.
And then they cancel. Bam, bam. Bam, bam. You guys with me? You guys see that?
Yeah, Flintstone.
So really, eventually you get to a point where once you have all the bottoms and an equation equal, you can basically just cross through them all. Because hopefully you'll understand you're multiplying by them, so they all will cancel. You can only do that in an equation because then it has two sides that balance. How are we doing? Let me stop there for a minute.
Can you say that one more time? What you canceled and did?
So I made them all the same by giving them what they were missing, and then I multiplied both sides by this. Yes? And so it goes here, it distributes here, and it goes on this side, and it cancels with all the bottoms.
Do you multiply
So now-
the top?
What's left to multiply the top with? That canceled.
Okay.
Do you see that?
Yeah.
All right, good. Don't forget that.
Okay.
The tops aren't going to change more than what they did when you made the bottoms the same.
So like you did with the 12s and with the
Yes, this is exactly the same problem. It's just that the bottoms are variable expressions instead of numbers, but they have to work the same way. What do I have left? What's left alive?
4x plus 2x.
Yeah, 4x plus
2 times x minus 3.
2x minus 6 equals 4x plus 12. Stop for a minute. That was a hell of a lot better, right? That's chapter 2 shit now.
And then
So see, do you guys see how the 4x just dies immediately?
Mhm.
Good job, 4x. And then
Add 6.
Add 6.
6.
2x equals 18 and x equals 9.
Now, the one little twist that these problems have, from the very beginning, can somebody tell me what values of x could never be solutions?
0.
3 and -3. If I did get that down here, that means that there's no solution. If I would have gotten x equals 3 here, that answer would have freaked this bottom out, therefore there's no solution. And the last thing I'll say is this. I always feel like I have to defend math a little bit, but why does math sometimes give me a bogus answer? Because if it did say x equals 3, that means what did I multiply by at the beginning? 0. I'm not allowed to do that. So this is math just going, hey, you didn't know this, but you did something illegal. And then we're like, screw you, math. You told me something wrong. No, this is the only way math can say, oh, shit, dude. Freaky equation. No solution. Right? Don't take it like, what did you do this to? You guys understand that? Maybe? That was nice. 9 didn't freak anybody out, so we can leave it. Do I know that 9 is the answer? No, but at least I know that number doesn't make anybody freak out. Doesn't make anybody undefined. So the last step in these problems, make sure the solution you get doesn't make anybody undefined. If it does, you got to throw that solution out. So that's a little different. All right. Any questions about that? Probably so. So now we finished chapter 8. Somewhere over this weekend, maybe you can try some of that out and come Monday with questions. Enjoy tomorrow. Sorry if you have another class to go to, but I'm going to be out of town anyway. So I'm leaving right when it starts to rain, and it stops raining in Seattle today. So
So you planned it raining in Seattle.
apparently it does.